Okay, so now that we know how to formulate the sampling distribution of P, now let's actually start with our first type of inference procedure for this unit. We're going to be talking about confidence intervals. Now, in order to estimate an unknown population parameter, we will start with the statistic that provides a reasonable guess. The chosen statistic is called a point estimate for the parameter. So, do I want to write this in, or do I just... I'm writing it in. Here we go. Oh, no, she thick. Okay, let's do it a little thinner, but, you know, it's fine. I'm just going to lose it every time. Okay, so it's called a point estimate for the parameter. Now, a confidence interval, okay, I'm going to shorthand since you guys can hear me. Hopefully, that was my post-breakfast hiccup. A confidence interval uses sample data to estimate an unknown population parameter with an indication of how precise the estimate is and of how confident we are that that result is correct. So a confidence interval has two key components. An interval computed from the data, which is noted by parentheses A to B, and then a confidence level, which we call C. Now, a confidence interval has this general form here. It's got the point estimate, and so I'll keep that in one group, plus or minus what we call our margin of error. So we assume that the point estimate is an unbiased estimator of whatever population parameter we're seeking to answer. And then the margin of error is how close we are, right? Or how precise our estimate is. You've seen this typically in your science courses, and now we're bringing it into math here. Now, more specifically for a one sample proportion, our point estimate, as we've been talking about, is going to be p hat, which is our sample proportion, plus or minus z star, times the square root here of p hat, times the complement of p hat, all over n. And so this should be this, all of this is in the square root. There you go. It's a little chunky but funky. It's all good. Here we go. So our confidence interval for a one sample proportion will be p hat plus or minus z star times the square root of p hat times p hat complement divided by n. Ooh, try saying that 5 times fast. Now, that's what we're building up to, but we're really going to focus on just this general form here of the point estimate plus or minus the margin of error. And so you can really imagine that our confidence interval, and why is my cursor not moving? Okay, there we go. So a confidence interval is essentially this idea here. So you have a line, and perhaps the p hat is somewhere, here's our p. That is the parameter that we're estimating. And let's say I form an interval and it captures a parameter here and a bunch of places, and maybe sometimes the interval might miss the parameter. So essentially, a confidence interval, we're trying to guesstimate the true population parameter. Well, since this line here for these intervals would be between A to B, so let's put A over here, let's put B over here. All right. In order to find the middle of A and B, well, mathematically speaking, we're just going to add the interval and find the middle of it, essentially the median, or the average of the two values. So I would take my start point and my end point, divide that by 2 to find the point estimate here. So that will give us the point estimate. And again, this is just general. When we do a specific interval, that would be our p hat. And then the margin of error, since that was just half of this distance, well, the difference between B and A, it's just half of that difference. Or what we would do is B minus A divided by 2 will give us our margin of error. So we have our point estimate and our margin of error to find these population parameters and just the components of the confidence interval. Now, we don't know the parameter here, so we're using the given statistics to try and guesstimate or capture it. So we actually have two interpretations here for the confidence interval and the confidence level. So a confidence interval is interpreted as we are C% confident, not confidence, it's too late. We are C% confident that the interval from blank to blank, whatever our interval is, captures the true population proportion of blankety blank blank. You know, you're always taking the context from the question or the information presented. In repeated sampling of size, whatever your sample size is, C% of all constructed confidence intervals from this population will capture the true population parameter of blankety blank. You know, it's statistics. We love the writing and we love to explain what the math means. So let's go ahead and take an example here. Suppose a random sample of 100 teenagers in Florida reveals that a 95% confidence interval for the proportion of high schoolers who favorite chocolate ice cream is between 0.32 and 0.42. So let's... breakfast is really good today. Let's find the point estimate and the margin of error. And then let's also interpret our confidence interval, our confidence level, and then let's find out if it's plausible that 40% of teenagers could favor ice cream. So I'm actually going to only write out the first one, and then the rest is all going to be verbal. So I would put on closed captioning if I were you, so you can write that into your notes. Well, we have this interval here between 0.32 and 0.42. Now, the point estimate would be in the middle there. So to find the point estimate, or here, since we're working with the proportion, recall that we're doing this, p hat plus or minus the margin of error. I'm just going to put margin there. Okay, so we're going to find p hat by taking the average of these two proportions, because one's the start point, one's the end point, and ideally, since we're using an unbiased estimator, it would capture the parameter. So for here, we're going to assume that the sample proportion, or true proportion, is going to be about 0.37. About 37% of high schoolers in Florida like chocolate ice cream, theoretically. Now let's find our margin of error, and I'm just going to abbreviate ME. We're just going to now find the difference, or half of the difference, between these two. And again, I'm doing this because if 0.37 is the middle of this interval, so let's assume we have this picture here. So here's 0.37 in the middle of this interval, and I'm here from 0.32 and 0.42. I'm only looking for this distance here. We're about 5% off of the truth, or what we believe is the truth. So here, my margin of error is actually going to be 0.05. So those are just some examples of how you can find elements of your interval just based on the interval itself. And then we're going to learn in the next few lessons how we actually compute the margin of error. So now let's interpret the confidence interval, and I actually am going to use my handy dandy interpretations here. So I would say something along the lines of, we are 95% confident that the interval from 0.32 to 0.42 captures the true population parameter, the true population proportion of high schoolers who favorite chocolate ice cream in Florida. Because our sample is pulled from Florida, so I can't overgeneralize to all 50 states. I can't generalize to the whole world. I can only generalize to high schoolers in Florida. So that's how we would interpret the confidence interval, and that was a whole bunch of mumbo jumbo, so I'm going to say it again. Second time's free. We are 95% confident that the interval from 0.32 and 0.42 captures the true population proportion of high schoolers who favorite chocolate ice cream in Florida. So that's our confidence interval. The confidence level would sound something like this. In repeated sampling of size 100, 95% of all constructed confidence intervals from this population will capture the true population proportion of high schoolers who favorite chocolate ice cream in Florida. Lots of writing, but we're going to be doing this so much that hopefully it'll start to come more natural. And whether we're doing quantitative or categorical data, the interpretations are still the same. Now lastly, we were asked, based on our interval alone, is it plausible that 40% of teenagers in Florida favor chocolate ice cream, and why? Well, looking at this interval here, I'm about 95% confident the true population proportion is between 0.32 and 0.42. So 40% is plausible since it is contained within the confidence interval. This would make it a reasonable estimate. So just something like that. Based on our interval, is this observation, is this claim true? Is it false? Do we have evidence to support it? Here we do have evidence to support that 40% is likely because it's within our 95% confidence interval. So it's a reasonable estimate of the true population parameter. So that's just an example there of the general confidence interval style that we'll be working with. As you can see, there's a little bit of math, but really there's a lot more articulation and reasoning that are involved with this type of inference procedure.